Okay, thank you. Good afternoon. My name is Seehwan from Dankook University, South Korea. Before making today, I'll talk about trustworthy ARM computers. Before I talk about trust computing, I'll introduce myself a bit more. Uh, Actually, I'm very happy to be here because my thesis is about mobile virtualization, running virtual machines over ARM devices. So I spent several years for working with ARM devices and working with virtualization, which is born here. So, and after that, I went to some company and did some research, make some research prototype for commercializing virtualization work, and I joined to university in 2014, and I do some research work on security and power performance scaling of ARM devices. Okay, trust in computers. Today I want to talk about trust in computers. And trust is related with some kind of general belief about working things. And the general beliefs about computers is usually my code and my data is correct and legitimate. And you are thinking about your code will work as intended, and your data are correct. Actually, I bought a house uh, a month ago, and I have a debt in bank for about hundreds of $1,000, and that has to be correct and accurately calculated. Otherwise, it is very difficult to believe the system. And the how can we keep trust is presenting consistency in behavior and data. Presenting the same data, if we don't modify, if it is modified by only authorized person or person, then that could be accepted and committed. And people in computers world, people have concerted an amount of effort and time to setting a concept of trust in computers, and they found that integrity in computer security terms is a core value of making computers trustworthy. To keep consistency in code and data mean checking whether the code and data are original and genuine. And without general belief, more than general belief, we need some verifiable proofs. So Trusted Computing Group, established in 2013, specifications around TPM device has been set out, and Trusted Platform Module has been standardized, and it actually measures the integrity of the computing platform. And for ARM, trustworthy computing for ARM is really important. Because ARM is one of the most popular computing platform in the world. So once it is deployed, then hundreds of thousands of computers have trustworthy properties. And especially when you think about some following cases, it is more evident. Smartphones, tablets, and smart devices are delivered to end users. You are buying your phone, and you need some level of security, and you need to work with trustworthy your mobile phone. And there are some special cases, some extreme cases includes some government officers use smartphones. Soldiers also use smartphones. Those kind of devices require one of the highest level of security. And for IoT devices trustworthy is not so obvious at the first time. But when you think about deploying sensor devices to large-scale sensor field, and if you want to have high precision sensor data, and how would you manage those sensor devices? Once sensor device is compromised and it begins to send wrong information, then your sensor devices, you cannot believe in the acquired sensor data, and it can hog some energy of another near field sensor devices. So security is one of the important property, and to keep your sensor platform integrity, you need to manage those sensor devices, and you need to sometimes monitor and update those sensor devices with some integrity properties, meaning that your sensor devices are running with original code and data. And ARM is making servers, so servers deals with corporate data. So it is obvious in those cases. So many cases that we need trustworthy ARM computers. And unfortunately, trust computing is actually difficult. Even for human society, trust is very difficult. Honesty, behavioral integrity, those are some words that explains trust. And how we can know if a person is honest or not. Since you are not, normal persons are not mind reader, you cannot know how another person thinks. In computer world, there is no things like computer do not deceive person, but you do not know what's actually happening inside your computer. That's because entire information flows are so complex, so it is almost impossible to keep track of the entire information flows. And more, there are human factors. There are some notion like said as benign computing. When you think of security or secure computing environment, then what actually antivirus software company does is usually restricting the execution of some code and restricting the access to some code or data and limiting accesses without knowing what actually happens to the user. So even in the case, some AV companies sends some private information to their company and breaching security, sending personal information. So in the case, humans do not believe in the AV company or some software. So owner should have proper rights to use his own assets. And limiting rights is not so good answer. And that makes people difficult to use computer, and that leads to people likes to find workaround. So basically, trust computing is difficult, and because ARM has many security use cases, ARM has considered security considerations and ARM has unique security features, trust zone from ARM 11. And ARM's trust zone provides separated execution environment, say secure world that is separated execution environment from the normal world, and you have dual set of CPU registers, dual set of caches, and DRAM peripheral devices are controlled by the separate access control hardware. So basically, it is all about isolation, limits access to secure world from normal. So secure world is said to be intact and trustworthy because it cannot be accessible. And this ARM also has some other kinds of approach, virtualization. It was originally designed for accommodating multiple virtual machines workload, and it can be also used as a means of isolating execution environment with some software layer that is called hypervisor. And today I want to compare this trust zone architecture with some other architecture. And that is Intel. And Intel has trust execution technology, TXT. And TXT has 4 components. It has to support virtualization extension. It has to support tamper-proof integrated measurement device. Said it needs some new instruction. Say get sec senter is a specific instruction that prepares clean execution environment. And fourthly, it needs some firmware called authenticated code module. So those 4 key components are essential hardware requirements for implementing Intel TXT. And there are some more software stacks that is specified, standardized in TCG stack. And they are actually original designed for costly servers. So my question was like, do we need all these hardware elements needed for ARM platforms? And if they are missing, then what is the reason? And why is trust zone enough to make platform trustworthy? So a comparison between Intel TXT and ARM. Intel TXT, suppose it begins with the isolated virtual machine environment and starts from the signed firmware. And then it checks all the hardware configurations. And then it measures all the integrity values, making hashes of execution binary and data as a part of tamper-proof measurement in a separate device. And then it boots up operating system and runs with the device driver of inside Linux and operates with the remote side server. While ARM trust zone with the secure world, it is just isolated execution environment. Trust zone API exists for interface between 2 world inter-world communication, and it supports operating system and it supports trusted application. So it is a full stack, separated full stack. And trusted ARM has opened an open software version, trusted firmware, as a part of secure world software. So the implication is simplicity versus flexibility. ARM's trust zone is all about isolated execution environment. So it simply isolates the execution environment and throws all the secure things into this trust zone. While TXT is for measure and validate. It much focuses on measurement and validate. Measurement device, so it needs measurement device, and we need validation software. To run validation software, we need a clean execution environment. So ARM trust zone, I'm not claiming that a trust zone is wrong or bad thing, but it is part of requirements, but it doesn't include measurement device or validation software. So good thing for trust zone, simple model, independent software stack, so all the software can be thrown to the trust zone. But normal world is not trusted, no proofs for secure world, no changes, updates are permitted. On the other side, Intel TXT, step-by-step validation. So we can check if there is a problem, then we can check and we can audit. So we can make execution hash and leaving it as a proof. So we can check which is the problem. which is the root cause of the problem. And we can accommodate changes in trusted software because it is based on the measurement. So when you update your software, then measurement will be changed, and you should have reference value that matches to your different changed hash value. So it is more flexible to accommodate changes. However, it is much complex than trust zone, and it is expensive because you need more hardware. So missing parts of ARM TEE establishment. Establishing TEE in ARM, my first claim is measurement and verification has to be separated. TXT defines TPM as an essential requirement, hardware requirements. And ARM TEE actually has some separated execution environment, but measurement can be performed inside trust zone. And you should verify the measurement also in the trust zone. In the case, how can you believe in the measurement is verified correctly? So to clearly distinguish verification software from the measurement, so we need two separate clean execution environment. But current ARM has only a single one. So the first claim is to measurement and verification has to be separated in separate execution environment. And those are the things, the right-hand side, SINIT AC module, right-hand side, lower, it shows some software code that is distributed by the Intel, which is the validating software. Second claim is ARM trust zone has no admission control at starting the bootloader. Actually, you may think about some secure boot, something like it. And except I will talk about that in separate slide. Without that, actually there is no admission control at starting the bootloader and operating system. Meaning your bootloader has to be clearly verified before it is loaded. And operating system also has to be verified before it is loaded. And so this right-hand side, this is the diagram from Intel TXT. Their yellow rectangle, yellow diamond shows there are three distinct admission control at the booting paces. SINIT policy, pconf policy, MLE policy. Those are checked, meaning SINIT policy checks the version of firmware, BIOS firmware. pconf policy checks the hardware configurations. MLE policy measures bootloader and operating systems. So they are separately checked in the Intel TXT, and ARM have some vague distinction. And even more, there is no security control policies. In Intel TXT, they defined LCP, launch control policy. So only the execution is allowed by these launch control policies. These policies, we can flexibly define those policies and store it to TPM MVLAM. And it is loaded when you boot. But there is no kind of security control policy, meaning that it is somewhat rigid. When you modify your code or when you update your trust execution software, then you should be able to give some flexible security controlling policies. So those are the missing parts of ARM trust zone. So those some security sensitive devices, we are missing something, and trust zone is also necessary, but is a simple solution. So it can be regarded as a secure plinger. So you can throw any security things into secure world, but we need further isolation. And as this is a kind of an example ARM-TE, so I'm here to, this is kind of initiative for making ARM-TE. I'm claiming that we need two separated, isolated execution environment, one for measurement, another for validation. So there is a secure world, trust zone, existing trust zone, and we can take advantage of hypervisor software. So hypervisor software and trust zone, two isolated execution environments. And tamper-proof measurement can be conducted in the inside trust zone as it is. And you can load security policies within the safe virtual machine, secure virtual machine, and you can validate it inside the virtual machine. You can think of many hypervisor software like Zen or L4 or different kind of library operating system with some lightweight hypervisor. And then we can implement measured launch environment, meaning that you should be able to execute program only after it is verified. And some comments on secure boots. You may know, some of you may have heard about UEFI, Universal Extensible Firmware Interface, secure boot as an optional implementation. And this actually, firmware has public key of operating system and software distributor. Operating system and bootloaders are digitally signed before it is distributed. And when the system boots, firmware checks the integrity using the HMAC mechanism. In this case, you have to think about initial key distribution. Actually, what happened in PC world, Microsoft distributes all the OEM, let all the OEM have their own keys to their firmware. So you can run Windows operating system. However, it doesn't support it by the Linux operating system. So Ubuntu still runs with Microsoft key, and to work around, they use different kind of bootloader instead of GRUB. So in ARM platform, there are several other approaches like using U-boot as a firmware, GRUB as a bootloader. But the distinction between this firmware and software in ARM is very vague. So of course it can be possible, but we have to double check whether it makes sense or not. And this is some things for personal uses computers, personal uses ARM computers. Actually, some antivirus software companies do benign computing, restricting execution and inspecting some programs, innocent programs, making difficult to use computers and snoop your installed program, send it over the internet while you don't know what's happening inside it. And it could be very similarly happen to ARM Trust Zone because Trust Zone is secured and code is not opened. So, and it is in the case, in this direction, ARM could face some security concerns around benign computing. So it is very difficult to earn credit and easy to lose trust. So please keep it open so that others can believe in trust zone technology and code bases. And there are several references around my talk. And so the summary. Trust computing for ARM. To my understanding, trust zone is a simple solution, and that could be improved to making ARM computers trustworthy by separating measurement from validation. To do that, we need to prepare two different isolated execution environments, and we have to mandate integrity measurement before starting operating system at very low level. And we should apply security policies to that. And virtualization is one possible approach to implement another next security execution environment. Thank you.
Thank you very much.